So without any further ado, and we don't need to take pictures because we are filming, Pedro Veloso from Audible. It's not an audible, but also visual. So have a good one.
Hello everyone. So today I'm going to talk about something that's very new, was announced at Google I/O this year, called Jetpack Compose. Sort of like this next generation of declarative UIs for Android. As Philip mentioned, I work at Audible in New York, but before I used to live in Lisbon, so I'm actually Portuguese. So I thought it would be like a nice touch to use some of the photos I took back when I lived here as the background for my presentation. So, what is Jetpack Compose exactly? Currently, if you go to that website there, which is the official webpage, you can read this thing that Jetpack Compose is an unbundled toolkit designed to simplify UI development. It combines a reactive programming model with the conciseness and ease of use of the Kotlin programming language. And you step back and you're like, does it come in red? What is this? There's a lot of fancy terminology in there, kind of hard to unravel unless you have like the proper context of it. So perhaps a better question is, well, do we need Compose? Some of you might be thinking, well, I can do everything that I want with the existing Android framework UI. I'm an XML ninja, I can do everything. Or some of you might be skeptical, and with good reason. Well, is this just another fancy technology that Google is doing, but you don't really know if it's going to stick or not? Well, in answer to that last one of the good news is that the team working on this is the exact team that actually supports the Android UI framework. So they are really invested into moving this thing forward. But what does that mean for us? Do we need it? And what would that look like? So one problem that usually arises in architecture is this discussion about composition versus an errandness. And the discussion that you have for whatever thing you're discussing on those two topics is the same here, so the same set of problems. But let's look at this example specifically. So all of these widgets from the Android UI toolkit I've been there since Android 1.0. At the very top, you have a view, and view has a lot of things in it. So one of the things, for example, is focus control. Back when Android was launched, people used to think that phones are going to be things that will have like sliding keyboards with arrow keys, or perhaps a joystick to move around, because that was very typical back then. But it turns out that reality didn't quite map to that. And that's probably one of the reasons why I suspect a lot of that code for actually handling three states, which is pressed, not pressed, and selected, is all the way up in view. So they thought, oh, probably this is something we're gonna need for everything because you need this joystick navigation. And there's quite a bit of code that goes just for that. And then you have everything that probably the team thought that they're gonna need in whatever widget you're dealing with. So things like touch listeners, handling the layout, sizing things accordingly, having padding, margins, etc. So by the end of it, the view class, if you look it up, is 27,000 lines of code. Then text view descends from view. Text view, everyone knows, like Redis text. You can select text. You can have drawables around the text. You can configure the font, have an int, apply some color on it. It ends up being this big class that also has 12,000 lines of code. And if you think about it, actually has those 12 lines of code plus everything inherited from view, which is another 27,000 lines of code. Button is really just a specialized, it's actually more simplistic than I was expected. It's essentially a clickable text view where they do something fancy to disable things. And here you can see the cracks of why inheritance is not a good idea. Because it actually is possible for you to enable text selection on a button, which is quite a weird behavior. And the reason for that is because the behavior comes from text view, so they disable it, but you can still enable it. And you can see that that's not ideal, because now every time that you would make a change to view, and now consider the whole set of widgets that you have on Android. Think that you're a Google engineer, you have to make a change in this 27,000 lines of code widget that's going to replicate to everything you know on Android. It's kind of a very scary thought to have. And finally, you have a checkbox, which unintuitively is just a specialized type of button, but you use a drawable, different drawable for checked and unchecked. You can go on with more and more widgets, but I think you kind of get what's the problems with this approach. So Jetpack Compose solves this by stripping all of those things into different behaviors and different composable functions. So down to the very basic things. So things like the padding or the margin, maybe that doesn't need to be built into the component, and could be something that is applied to the component. So that's the whole idea behind composition. Another issue with the current Android View framework is this big decoupling of UI and state. So you have your XML, it could be layouts, it could be selectors, your drawables, all these things, and they need to display data. But that data lives in your view holder, your activity fragment, or whatever other kind of things you're using that's similar to these ones. Now the issue with this is that, yes, the first time you do your screen, that's all fine, but then you go back and forth, you do other things, and there's actually no guarantee that if you add more data that you wanted to replicate to the UI, that the compiler is going to complain. No, it's going to be fine, because now you need to go and match all of these things manually, right? You added one thing on the XML on the layout, you added one property to your model, now you need to go to your activity and connect the two. Sure, there are some ways you could solve this, but it is still true that if you need to work that data or have more logic, you cannot solve that simply with data binding. And data binding itself is sort of a patch on top of a flawed system. There's other issues with this separation, and that is goes down to not having a single source of truth. So probably a lot of you faced issues like this in the past, where you have a checkbox or you have a slider. Now you want to change the value programmatically, but you also want to change the value when the user clicks it, and you have a callback that is called when this thing changes. And now you notice that the first time you run this programmatically, he actually calls the callback, which then, and this thing goes on, and it's a mess. Compose solves this by having the data living together with the composable functions. You can certainly decouple it with some work, but it kind of enforces a single source of truth. And it takes lessons from other things that are out there, like Redux, where you have this idea of unidirectional flow of data. You think about, you have a model, now you handle that model to your composable function, and it takes care of rendering it. If you add something, or you remove something, then that immediately gonna break. And with this, actually Compose adds another thing, which is the concept of tracking the state of your data. What I mean by this is, and we'll see that later on, is that you can have a model that you're going to display, and now you wrap it up with this thing called state that comes from the Compose library, and with that, it generates a sort of observable that every time that data changes, Compose knows exactly what it needs to invalidate and to re-render. It does that by something called the gap buffer, which I'm not going to get into detail. Lastly but not least, Compose is not going to be part of the Android OS. It's always going to be something that's apart from it, just a normal library on the Jetpack library. And the reason for this is, historically, Android in the very beginning, I know many here have been doing Android for quite a while, But they had this idea that, we think manufacturers are gonna want to create value by having different customizations on their UI. So in the very beginning, you had things like Motorola phones that once you run your app there, the whole thing was red because there was like the Droid phones. Or Samsung phones where all the checkboxes look different and they have like different graphics for everything, and all you're doing as a developer is just using the default theme. Once you notice that, and your boss came to you, oh, why is this looking like this? Then you had to basically go and force things to be a specific type of asset, which was a lot of work. The platform didn't really evolve in that way, so Google started to tackle these things. And it started to make things a bit more uniform, and now, fortunately, it's a little bit more sane to develop for UI, but it is still the case that if you're using the defaults and you're actually coding an app that is meant to support a lot of versions of Android, you may be surprised that when you run your app on an older version of Android, it will look slightly different than you expect. Of course, we solve these with things like Jetpack, formerly the support libraries, which kind of abstract this thing from you. The other downside is that Google pushed out material design up there, and then you went and looked, and oh, actually a lot of these things don't exist in the Android framework, and you had to use all of these third-party libraries. Eventually, we had the material components library. So all of this to say that it is already the case that if you want to build a consistent look across Android manufacturers and Android versions, you have to include all of this stuff to do that. So why not just give something that already does everything that you need? So that's the idea behind Compose. Here are some helpful resources that I looked into when I was learning about Jetpack Compose. The first one is a podcast. I found it really interesting because it talks about how the Kotlin compiler is actually who's under the hood to do the things that Jetpack Compose, the code generation that Jetpack Compose needs. It turns out there's a lot of similarities with how coroutines are done. And it's made by Chad Hayes, Roman Gee, and Tor Nobais, with like all known engineers from Google. It's quite a good talk. The second one is a post by Leland Richardson. He's one of the engineers working on Compose, and he kind of tells from the very basic examples, builds up something that's similar to Compose, which explains why it is built the way it is built. Here is one of the places that you can kind of, if you're interested in those things, you can look how Compose is actually very efficient to only validate the things that have changed through the gap buffer. That's a good place to check. And lastly, if you want to play with Compose yourself, you can go to the official page. There's a get started. I'm not going to do that myself because there's already a lot of talks that cover these things. That's why I'm mentioning them as helpful resources. What I really want to do is something more hands-on, which is, if you started coding an app nowadays and you wanted to use Compose exclusively, how would that look like? So let's start with something simple. I thought about, a good example would be like a weather app. Everyone can relate to weather apps. Everyone has used one or seen one pre-bundled with a phone or whatever. And they can be sufficiently simple to be a good demo, and they're usually very visual as well. So I made this wonderful prototype on my sketchbook. And I set up some goals that I wanted to accomplish. So, I wanted to show the current weather, the minimum and the max. That seems pretty common. I want to have some graphic, because I'm a very graphical person. I like to have some graphic to quickly glance, oh, it's going to rain today or not. I want it to look material, because what's the point of using something new if it's going to look old and outdated? And I also want to be able to see the forecast for the coming days. So before we jump into the code, let's see what are the things that you can use to build such an app. And to do this, I actually had to look to the source code. There's no documentation at all. You just have to download the whole Jetpack library and look at the source code and go through it. So that's exactly what I'm going to show. Compose works with this concept of composable functions. Everything is a function that you see in Compose. So in Compose, one of the very basic ones is this thing called the column. I realized, and I don't know if that's by design or not, but the Compose is very similar to the web, where you certify things in like a grid way, as opposed to how we used to do it on Android before. So I want to call out one of the parameters here that they have, which is the main axis alignment. So a column is just something that, if you read the description, a widget that places its children in a vertical sequence. This is sort of like a vertical linear layout. And what this parameter is saying is, look, my main axis, which is a vertical one, you can specify how I'm gonna align things. You can see that the default is start. So this means that in a column, the default is to start at the top. Conversely, the cross axis on a column would be the horizontal one. So with this, you can say things, I want to display my children vertically, but I want to align them on the horizontal axis. And this is the one you use. And I'm going to be using this for the prototype that I showed. Another thing we're definitely going to need is to display some text. The syntax is quite simple. You can see that the only mandatory parameter in there is the text. Everything else is optional or as default values. And I kind of left the whole parameter list in there because it kind of highlights this thing, which is the code is full of to-dos. And this kind of speaks to how early on in pre-alpha Jetpack Compose really is. This thing isn't meant to be used in production at all. Google is doing it out in the open from a very early stage. And in a fun way, by reading a lot of the code, I got to know pretty much everyone that's involved in building the code, even though I haven't met them in person. I'm going to need to do spacing out of items. So for this, there's something called the width spacer, which, as you can imagine, spaces things out horizontally, and you can provide something form of DP. Actually, if you look at the implementation, that's the full implementation, and even fixed spacer is like 2 or 3 lines. They have this extension function on numbers that you can just do a .dp, and now you have a dp measure based on an integer. And a lot of Compose is very idiomatic in this way. And then the height spacer does the same thing, but vertical spacing. Finally, it's useful to add some padding, just quickly glancing at what it does. And they even provide sort of like an example in there, which is very useful. And you need some way to do theming. Theming is going to be working differently than it worked before. It's not going to be something that comes from resources. The way they're doing it is, again, you have a composable function that you apply to your other composable functions. This is how you declare it. You have something like the colors, where you set the primary, you assign this to a variable. Then you can have different types of typography, and you specify as much or as little as you want. You don't have to have all of those parameters. So a lot of these things have a lot of defaults that you can just use. I'm not including the whole typography in here for the sake of space, but you kind of get the idea. It's going to be just a list, a lot of things that look like this. And at the end, you just apply something like that. Assign the colors and typography to something called the material theme. And I want to call out just the name that we're using because we're going to be seeing that before. At the very top, you can see Compose Weather Theme. So this is the thing that I'm going to be applying to apply the theme that I did for my demo. Just going to give a quick glance through the models because, as I mentioned, in Compose, the UI and the state live closely together. So it's useful to just know how the models look like. I'm not going to spend too much time on this, but so I created a temperature data class that has Celsius as a double, and then as a way to print the value based on if it's Fahrenheit or Celsius. created the daily temperature, that is basically the current, the max and the minimum. I'm basically consuming the data from open weather or something like that. And then there's an icon. I noticed that actually there is a lot of to-dos related to inflating a drawable. So the way for me to go around this, I'm just using an enum to map the state to an emoji of the weather. And finally, I have the weather data. This is a thing that I'm actually going to pass on to my model, to my composable function. I was kind of getting ahead of myself. And you can notice this thing as this annotation called add model. What this thing does, it does Compose to observe changes made to this specific class. And again, this works with the Kotlin compiler. So calling it an annotation is really not kind of the right name, but for lack of a better name, that's it looks like an annotation. But the point is that this is actually not being handled by an annotation processor. An annotation processor usually runs through your code, finds an annotation, and creates another file. The Kotlin plugin, what it does is actually it writes in this code, sort of like a macro in a way. Hopefully it will be faster than annotations. So how do you actually build the annotation, the activity? You have this extension function that's been declared for activities that is actually also a higher order function, so a function that takes another function that takes a composable function. And this is all you need to actually just say, oh, render this composable function. And the composable function looks like this. So at the very top you see that there's that annotation called add composable. So that's what makes it, what signals it to the compiler to look into that. And then I want to call out this syntax here, which just creates that state for the observable that I talked about. You can see that I'm applying my theme, and then calling something called weather screen body, where I pass the weather data. And the idea here is I'm going to put everything that I need in weather screen body. So because this is wrapped by theme, the theme is going to be applied to everything. So displaying some stuff. That code on the left generates the UI you see on the right. You can see that we're passing the data here. It actually creates this type called the state. Then we're just getting a lot of syntax, but basically just getting the temperature for today of type temperature. And now let's actually look at how those things are constructed. So this padding just says, look, everything inside of this block, just give it a padding of 16 in every direction. Then we have a column, so I want to lay things out vertically. But I also want them to be centered horizontally. And actually, you know, it looks a bit nicer if you give a little space at the top. And finally, I render my icon, and I apply my H1, which is like the bigger text, so that sun with a cloud looks a bit bigger. And in the bottom is similar thing, but I'm using an H2. And at this point, I kind of realize, like, if you're not careful, you're gonna end up with like these big cascades of just a lot of blocks, right? The good thing about it is that, you know, we have a lot of clean code practices, so it's fairly easy to kind of handle that. So I decided to want to start to clean up a little bit. And once you do, basically I just create another composable function and I passed it down to put it there instead of all the code that I had before. And for the purpose of this demo, I kind of consider this weather screen body to be like the top level UI that's just going to delegate stuff around. So then this is the actual separated function, and I extended it a little bit by adding the max and minimum temperatures. You can see here that, you know, there's like the slash that separates the two, and I'm basically just using string concatenation to achieve that result. So nothing real fancy there. So, okay, so I have my header, And now I want to build like the forecast for the coming days. And for that, I thought about using something from material design, which is the card. And I, search it up on the IDE, and sure enough, there's something called the card already in Jetpack Compose. And if you notice in the card, you also see that the items here are actually laid down horizontally rather than vertically, except for the last part where those two temperatures are like vertical. But first I need to lay out things horizontally. And for that, we need to introduce something called a flex row. There's a reason why I'm using the flex row and not the row, but that will be made clear in a bit. And again, one thing that I just want to call out here is that this parameter has the same name as the one you saw in column, but you have to consider in a row, the main axis is actually horizontal. So the logic is flipped with the column for these two parameters. When you use it, it kind of looks something like this. You have a card. I decided to override the color. I could have done it in the theme as well. And then I added the padding, so I have something like this, like the content is going to be somewhat far away from the edges of the card. So this is how the actual implementation of the card is going to look like. So let's go one by one. In a flex row, I'm saying, you know what, in the cross axis, center your child elements. So the cross axis is not the main axis of the row. So that would mean like the vertical axis, because I want to have my content laid out vertically centered on my card. It looks nice. Then I have something called inflexible, and inside of it I have a text. Inflexible just tells that wrap the content tightly together and don't allow anything else to rob you of this place. It's something that you use in a flex row. Then I have an expanded. And what this says is, with this specific parameters, is consume the remainder of the space. So if you look here on the bottom, you see that they look like that, and with the expanded, you would occupy everything. Of course, I'm not considering the bottom two. I'm going to consider that in a while. But that's how it would look like if you have just the top two. So once you add the other two, because they're inflexible, now the expanded one shrinks to accommodate for the space for those two. And one thing you can see is that I'm actually giving a little space between the icon and the minimum and maximum weather. And for that, for the sake of cleanliness, I also declared another composable function that basically just has a column with two texts. That's it. So you can see that this is actually, once you realize the basics, it's actually very easy to kind of build up this stuff. The whole card code kind of looks like this, and the comments that represent the code that we just saw, just to have an idea of how this whole function looks like. And now that I have the single display for a card, I want to be able to display a list of cards. And that's how it looks like. And the code, this is the code I added in my main weather body function. The one thing, I'm not sure how familiar people are with Kotlin. So in Kotlin we have this nice thing that if you have a for each, but you still need to actually look at the index, you can just have collections dot with index, and now this thing gets destructed into this tuple that has the index and the element. So I just use that, and then I just call the weather element with the parameters that I need. You'll notice also this this thing here. So this is just to give like that space between the cards, and this is the actual thing that renders each individual card. But then I went and played with this, and I realized one problem, which is this thing is not scrolling. And that's actually a very easy fix. You just have to use something called vertical scroller. Very intuitive name. There's a lot of parameters in there. I'm not really gonna read all of that, but basically all you need to know is the thing that says on the top, container that composes all of its contents and lays it out, fitting the width of the shell. And you'd apply it something like this. And then it does scroll. So you just wrap that whole block with this vertical scroller. So just for fun, this is actually the whole, I mean I removed some comments, but this is actually the whole UI plus state managing code that builds this whole app. Which is quite concise if you look at it. It's 88 lines long. So, what did I learn with this experience? Jetpack Compose definitely feels modern, feels closer to some of the technologies that are coming out for other platforms like SwiftUI or what happens in React. It takes a lot of good lessons from how to make it idiomatic and feel very Kotlin first. It is nice that finally, we have this thing that's the only thing that you shall need, so bundle that application. And actually, by the end of it, even though there was no documentation, it was fairly easy to me to figure out just by reading the code. When you have good, clean code, that's usually, in my opinion, better than documentation, because the code will always tell the truth of what it is. And if the code is small, then it's easy to kind of understand how things work. Some of the cons. I remember when Kotlin was coming around, one of the things that made like a huge argument was that the tooling was really good. Like IntelliJ really made a good, you had the converter, you had all these things, it was completely interruptible. While I was doing this, I realized, oh, you know what, there's no more find view by ID, so everything that like this thing to inspect the hierarchy, or UI automators, or Expresso, all these tools that you already know and use, they're just not going to work for Jetpack Compose unless they are adapted to do so. And it probably gets even more problematic for all these third-party tools like Appium that rely on this very unique mechanism for find view by ID, click here, click that. It would be interesting to see if we're going to have some different type of tools to handle this, because now you have a lot of state that lives with the UI as well. So what can you do with that? The other cons that I have are mostly things that probably are going to go away very easily. So missing documentation, I'm assuming they are going to tackle that. And there's actually missing use cases, so I couldn't just use a drawable. That seems to be still in development. And it's sort of unclear how do you handle things like device configuration change, or how do I even approach if I'm designing an app for a tablet and for a phone? Do I just make two functions? Do I make a function that takes a parameter? Then it may get messy. One of the things that I think is promised with Jetpack Compose is the live preview, but that's not there yet, so every time I made a change I need to compile, wait for like 2 minutes. But I think eventually it's going to be there, and it's going to be just, you make some change and you see it reflect immediately. And the other thing, I don't know if this is actually a valid point or not, but I've seen designers actually doing things in XML and actually Zeppelin, which is one of the tools they use. They can export to XML and they can do some tweaks. I mean, this seems like a stretch for them to actually do any sort of changes, because this is much more as a programming language. And that's all I have for today.
Questions?
Great talk, by the way.
Thank you.
Will you personally miss XML when Compose comes out?
I mean, I've been doing Android since the early days, so I kind of, I can read XML pretty well, but I don't think I'll be missing it, especially since constraint layout was introduced, and a lot of people are doing a lot of drag and drop, and when you look at the XML, it's getting more and more like iOS, so more and more I'm feeling averse to looking at it, and this is, yeah, I like this.
In Android, we have a lot of useful custom views.
Mm-hmm.
Is there a way to reuse these views in Compose approach?
Oh yes, there is. Actually something that I didn't show, and it was in the code, they have examples for that too. Basically, Compose will be interruptible with the existing view system, and you can actually build the previous things like linear layouts and etc. in a DSL way. But when you're doing that, you're missing some of the benefits of Compose. But of course it makes sense, like you said, like a lot of people, they're not just going to start an app now. They have apps that exist, they don't want to rewrite the whole thing. So I think interoperability is something that they're betting on and definitely is going to be important moving forward.
Okay, thank you. And second question, what kind of architecture do you suggest for Compose?
I think it's way too early. I'm interested in seeing what that will look like. So as you saw, like the activity and activity lifecycle are still things, but it kind of raises the question, do we still need fragments or will we have something else? Kind of interested in seeing how the community will kind of, all the things that will probably change how development works nowadays as this gets more and more adopted. Yeah.
Thank you.
Great talk, thank you very much. And quick question, do you have any issues with context, passing context? I read something about the brain wrapper. Was it necessary? Do you have also necessary at this moment?
I never handle context at all in this demo, and on my, so I actually don't know. You can look at the code that it is generating. I don't know if it is hiding that from the developer. I assume so. You still have to be careful to do things in the main UI thread versus, so like you don't want to update some view or a data model that's going to replicate a change in a background thread and not atone for that. I think that's still going to happen, I think.
Thanks.
Sure. I feel like you guys are not calling me like
That's on purpose.
Does Google have an official release date for a fully?
Not that I know of. It is interesting for if you want to follow, they have a Slack channel. And it's kind of where I get the change logs and things like that because they don't even have like a page for change logs. It's just like one of the team will come and like say, oh, yeah, we released something else, and then you just go on the command line, you get the latest version of Jetpack into your local machine, and you kind of check it out. But it's fairly early on.
Hey, do you have any ideas how will they handle resources, like multiple languages?
Yes, I think resources are already there, so you can handle things like the language of the. I mean, you can definitely, in the activity context, get a string and then pass that string down to your compose function, right? And that string will already be considered the resource. So if the user is English versus Portuguese, you'll already be giving you the proper string. I assume there's going to be minimal effort you need to do to consider this. I think where they're having most issues now has to do with all of those layouts and how you actually integrate existing Vue UI with the Compose UI.
No more questions?
All right.
Thanks.
Thank you very much.
Rest on